Hi, this is Andy Reagan. I'm going to share some tips and tricks for visualizing data in Python, particularly, and we'll explore Matplotlib in a little more depth. So, just first thing to say is that for looking at data in Python, there's a whole bunch of different packages that exist. Matplotlib is probably the biggest and most documented. I came from MATLAB originally, and Matplotlib has an interface that's very similar. The lead developer also came from there. There's a whole bunch of other libraries. I'll say that Pandas, Seaborn, and ggplot, they're all thin wrappers over Matplotlib. So they're pretty cool. I haven't used them very much in particular, but you're welcome to try them out. They're going to help you make more complex plots and use default styles a little bit better. In addition to those three, I'm also mentioning kind of what else exists, right? So there's Bokeh, which I know less about, but it can render to SVG or PNG backends. It's not a wrapper over Matplotlib. PyGel looks, I poked around, it looks a little more limited. And Plotly uses the plot.ly API to produce web graphics. Also, so I'll say that Bokeh is designed to produce graphics using a web backend, and we'll see you can actually do that in Matplotlib as well. So first thing, let's just go ahead and look. So this is the main page for Matplotlib. It was developed by John Hunter, who has since passed. So you can go here and explore the documentation. A few things that I pulled up. One of the biggest problems that people will have with Matplotlib and why some of these new packages are wrapped around it is that the default styles aren't always great, right? So they've kind of introduced this new thing that has a style sheet. So you can load a style context. So here's a 538 graphic style sheet. And one of the other examples I thought I'd share is there's even a ggplot style, which is going to make some better initial choices of colors. And then one other style I want to share that's particularly fun, right, is they made the xkcd function on the core pyplot interface, so you can just apply it to any graph, right? It'll load the Humor Sans font and make all the lines a little squiggly. So I think that one is pretty fun. You can go and look at the screenshot examples, and there's a lot more, right? You can you can render in LaTeX and default, and you can even display 3D stuff. So there's a lot here. Feel free to peruse on your own time. And for the documentation, I tend to use the pyplot interface, which you can get to from the main documentation page, right? So I'll go here to look at the gallery, and so also the plotting commands, right? So this is where I'll find most of the plotting commands. It's on this pyplot interface. Generally, I interact with it using the dash documentation engine. So here I happen to be looking up how to use a legend. All right, so I'm going to go ahead and share a couple ways to make graphics. So the first way, is if it depends on your workflow, but if you're working on the command line and you use Python, you might want to make a graphic, just write in IPython. So we can go ahead and do that. Spin up IPython, right? We're just going to import Matplotlib, right? And I'm going to import the pyplot interface. So I'm going to import that as PLT. Right, I'm also going to import Numpy so I can make up some data to plot here, and just as a quick first plot, right? The default plot interface is just plot.plot, right? So we can make a simple plot using just this interface. So let's make some data here. So let's just plot numpy.arange of 10. So this will plot the numbers 0 through 9. Right? It's made the plot, right? You can't see it. So what you need to do in this instance is go with the plot.show command, right? And it's going to pop that up. Here's your plot window, right? And this is similar to maybe more like R or MATLAB, that it pops this up, and you can zoom around, so all sorts of things. It is an interactive graphic here, right? And then from here you can actually save it, right? So you can save this figure from here. And that's one way to look at it, right? When you closed it, the plot is now gone, right? So there's nothing to show. So we can plot it again, right? And if we want to save that, we can use the plot.savefig, right? There's a command to save it, right? And we can save it as, myfig.png, and it'll save it based on the file extension, right? So we have that now, right? I can open that, right? Well, it's not going to work in IPython, right? But okay, so we can take a look at that. So that's using the IPython interface. You can also do it right inside of a script, right? So if we wanted to just run a script to plot a figure, right? I think that that's a pretty powerful way to do it, right? So if we just wrote a function, right? We're going to call this, simple plot.py. We have a simple Python script here, right? And when we run this script, we could do the same things we did over here, right? We're going to want to import Matplotlib, and I'm going to import the pyplot interface as PLT, right? And then also we'll just load Numpy, right? And then let's just go ahead and make this same plot. So we're going to make this same plot, and let's see what happens. So let's run that. Let's just run Python simple plot, right? Okay, it plotted it. It didn't really do anything with the plot. So again, we can go ahead and show that plot. It's going to pop it up just like it did before, and when we close it, then the function will continue, right? If we want to save it, again, we can save, use the plot.savefig, right? And we'll save it as, myfig2, right? And it'll save that PNG. So we can run that, right? It's going to save PNG. It took a little bit longer. We can look at myfig.png, right? Here's our simple plot, right? And we can also look at myfig2, right? Here we go, same plot. There's a few things that you'll find useful. So I redefined my own Savefig function, which I'll show you in just a second. Okay, so I usually tend to do my plotting using the Jupyter notebook. So here's an example notebook that I spun up, and I'm going to load some data in here. So I figured we could go ahead and take a look at a plot of Harry Potter. So we're going to look at the happiness over time in Harry Potter. So here's just some default loads. I'm going to go ahead and load the data. Right, this is kind of my default Matplotlib load. I'll set some parameters. Right, I will put this graphic eventually into a paper, so I'm going to use the same font that I do in the paper, which is the Computer Modern. But you don't need to do that, right? So I'm actually going to comment all this out to start. Right, we don't need to do any of that. I'm going to load the data file that I need, right? And I will go ahead and make a couple time series, right? So if we want to go ahead and plot, we're going to need to, of course, load Matplotlib. So we can import Matplotlib, right? And again, let's import the pyplot interface to pyplot as plot, right? So we've got that loaded. And then we can just go ahead and plot we go ahead and plot some stuff. So let's plot the time series, right? So that's going to generate a plot, and by default the style is inline, right? So we could try to do something like this, but we're not going to need the show command because it's going to show by default, right? Okay, so you could also set the backend specifically using this the IPython magic command for Matplotlib. It's built in, right? So it's going to go ahead and show that inline. And there we have it, right? We can go ahead and save that figure out, right? So do plot.savefig, right? And this is going to be our third figure, right? And there we have it. We can go back and we can open that figure, right? So we can go look, and we're going to have a different figure this time, right? But here we go, is that time series. Right, there's a whole bunch of options, of course, like you'd expect, right? You can set the DPI, right? So we can change the image resolution, right? That's a much higher resolution image. So now we'll see that, yeah, this looks a lot better, right? And we can go ahead and set some default styles. There's a few different ways to interact with Matplotlib, and just as a final note, I'll show the way that I usually interact with it. So you have plot.plot is operating right on the pyplot interface, but what I'll usually do is I'll create a figure instance, right? So I'll say fig is plot.figure, right? And you can pass it the actual size of the figure. This gives you a little bit more control, right? So here I've created a figure. It's 6 inches by 6 inches, right? And then on that figure, I can create an axes object. So I'm going to say my axes is figure dot, I'm going to call the add axes command, right? And I'll pass it a rectangle, right? Which will be, in this case, it's from 0 to 1. So I'm going to pass it from 0.2, and then the width and height. Right, and then I can actually add plots right onto that axis. Right, so we'll go ahead and see that this will go ahead and plot that plot that figure equals, right? There we go. So we went ahead and added that plot, and we had a little bit more control over the size. Now you can see it's square. If we want to make it a wider time series, right, we can make that whole figure a little bit wider. So it's going to be X, Y, and that gives us a little bit more control. It's pretty easy to do the, things like to change the styles. So for example, if we wanted to XKCD this, right, we can go ahead and do that pretty easily. I have the Humor Sans font installed, so it should render it. So I think we're actually going to need to set that first, right? And it might take it a little bit longer to render, but there we go. And you can set, you can use real styles. Okay, now let's just make a couple more simple plots. So we've made a time series, and of course you can do any kind of plot you can imagine using Matplotlib, and it gives you pretty close access to the API, so you can do custom stuff. But for example, let's do a histogram. So we can follow this kind of the same syntax here, by defining a figure object and then creating an axis on that object, and we can use the AX that's got a built-in hist method for doing a histogram, right? So it's going to go ahead and bin those values of the happiness on the time series, right? And you can pass it arguments like bins, so we want to do 50 bins. We'll see a more refined example here, right? We'll probably want to turn the XKCD style off, and so you can set that. For example, we could also do a scatter plot if we want to look at, like, the autocorrelation or something like that. So we could look at the time series up through the last point, right? And we could look at the time series from the first point forward, right? So we're going to do this as a scatter plot, right? So it has all of these default options, right? So we can go ahead and make a scatter. Oops. So we're going to need the time series, right? And we can see that generally there is some autocorrelation in this time series, right? If you want to go ahead and fit a trend line, you'd need to use, and you want to use Matplotlib by default. This is some of the things that, like, the ggply and some of the other Matplotlib wrappers will provide. But you could go ahead and fit that line using a Numpy linear regression, and then plot that line using ax.plot. So for example, if we wanted to plot a line, right, we could pass it our x values. So we can plot the line from 5.56 to 5.71, right, 5.71, and our y values are going to be, again, probably the same, right, 5.56, 5.71, right? That's gonna give us a line on there, right? And we can go ahead and we can change the line style. There's the default colors that are like MATLAB. K is going to be black, right? We can then pass it a line style, so we can make a dashed line, for example, and then we can also give it a label. So I give it a label. This is the line of best fit, right? We just made this up, of course, but there's a line of best fit, and if we want to actually show that, right, we're gonna just give it the legend. Right, it'll put a legend by default in the upper right. You can do things like pass it that the location. We're going to give it best, so it's going to try to not overlap it. Oops, so it might be loc. Loc equals best. Yep. So there we've got a line of best fit. We could also label the scatter points. So those would show up if we gave them a label. Right. We could also just pass the labels to the legend object, but these are our lagged points. Right, so there we go, and it's going to go ahead and label that for us. Similarly, as you would expect, of course, it's going to have the, we can set the X labels, right? So this is
time t, right? And we can set the y labels. One of the things that, of course, like most of these packages do, it's going to set the y label. This is going to be time t plus 1. It's going to set it vertically. One of the things that I like to do is I'll go ahead and grab the y ticks and I can put it at the top tick. So one of these examples I had open, I had done this. Maybe I've closed it. But you could go ahead and do that. You can gain access to the ylim object and replace that top ylim, for example. And that's really all I want to show you guys. I'll go ahead and go over a few more tips and tricks, and that's our demo.
So just as a few final notes, I thought I'd mention the NPL D3 package, which you can install through pip like you did Matplotlib. And it allows you to take a Matplotlib graphic and add like hovers, some basic move around interactivity, and it does this using an HTML backend, so you can display them in a notebook, right? And then you can put them up on the web. So I think it's a pretty cool way to add a little bit of interactivity. I don't think it does a good job spanning the gap to where you're going to go edit that with D3, but that's another story. And also go check out the gallery. There's a lot of inspiring examples of things that you can do with Matplotlib. So I put the link here, and I mentioned that I would show you guys my Savefig function. So I have a wrapper around this where I'll call my Savefig, I'll pass it a file name as name, and generally what I'll do is I'll prefix, when I'm making figures, I'll prefix everything with a date timestamp. So I can see all the versions that I'm making, and I can go back if I wanted to. So I'll pull out the date, right, and then I'll actually go in and prefix the file by the date, and I'll copy the file name into my clipboard and optionally open it. So there you have it.